basis and the underlying concepts. Are there any practical applications?
There are two broad areas of applications of ion resonance. The most important one by far deals with the medical applications. But before I discuss that, which is a little more involved, let me just point to the commercial applications which are being considered by a number of people. For one thing, we know that we can produce ethanol from biofuels, from corn, more rapidly, very rapidly, perhaps 35 or 40% faster using I.C.R. magnetic fields. In addition to that, there are discussions underway involving the effects on water. Water has always been a very interesting thing in terms of its potential response to magnetic fields. Most people don't understand, and I must say still don't understand, what happens in water. There are people who claim that water is magnetized and so forth. However, we think that the mystery of water, in terms of its physical properties, will be greatly reduced by looking at the ion resonance effects in water. And one of the areas we're considering is the area of either water desalination or water purification. In addition to that, a lesser known application of I.C.R. has to do with bird navigation. I published a paper a few years back in which I pointed out that if you use oscillating magnetic fields parallel to the Earth's magnetic field, you'll get a resonance, but you can get the same sort of resonance by using oscillating electric fields perpendicular to the Earth's field. This concept was woven into a model for bird navigation that is now a contender, along with 2 or 3 other models that people are considering. Bird navigation, animal navigation in general, is one of the major mysteries in biology. Not only birds, but many other animals make use of the magnetic field of the Earth. And we think it's through the ion resonance approach. The medical applications are quite diverse. By far, the most important medical application was to repairing bone that does not knit. This is called ununited or non-union bone. The original concept for using electromagnetism dates from the 1970s, when the late Andrew Bassett applied very large magnetic pulses to induce currents directly in the fracture site. When we looked at this problem some years later, what we did was to replace the very large magnetic field that had been used in so-called pulsed magnetic field, or PMF, with I.C.R., and we found that we could reduce the effective intensity and energy that was being used by more than 100. This led to the use of I.C.R. in terms of bone repair, to the point where now hundreds of thousands, perhaps 1 million people have already been treated. The techniques that are used have been approved by the United States Food and Drug Administration, and these involve not only fracture repair, but also the idea of taking the spine after it's been operated on and fusing it more rapidly. In addition to that, there have been results involving applications of I.C.R. to treat cancer in rats and mice, so far not in human, but that day is coming, using a very, very weak I.C.R. magnetic field. And also, we can't forget the use of the Seqex device, which has been used in a wide range of applications involving I.C.R. These applications involve treating people for personality disorder, treating people for multiple sclerosis, treating people who have problems with their chemotherapy. One of the big problems in people who have cancer is that the chemotherapy, they say, sometimes is worse than the disease. And what has been found by Dr. Rossi in Genoa is that I.C.R. treatments using the Seqex device actually affect the free radical formation, and people who have problems resulting from chemotherapy, the problems basically are diminished, they actually go away. Also, autism has been looked at, and a number of other diseases. So I.C.R. is used widely when you look just at the spectrum of treatments that are possible using the Seqex device. I also should mention two others that are not connected to Seqex. One is the result obtained in Italy using I.C.R. to differentiate stem cells for use in heart disease. Heart failure is a disease which occurs when, after a heart attack, there are pieces or areas of the heart muscle that are basically unable to regenerate. Muscle in other parts of the body regenerates readily, but in the heart it's much more difficult. What is done now is to take stem cells, heart stem cells, and treat them with I.C.R. magnetic fields. And in this way you can differentiate these cells to where they can be used directly injected into the heart muscle to regrow heart muscle, and thereby perhaps prevent people from having to worry about heart donors, organ transplants, and things like that. So from the standpoint of regenerative medicine, it's an extremely important possibility. Finally, I had done some work just last year or so involving mitochondria. We found that cancer cells, which all cells have mitochondria in order to keep them active and functioning, we found that we were able to change the nature of the mitochondria in cancer cells specifically as compared to normal cells by using I.C.R. So there's a possibility there for more profound treatments involving I.C.R.